This week in green, we have a plastic pollution problem, and the only way to fix it is to just eat it. Well, obviously, we as humans can't eat the plastic waste, but what if something could do it for us? That's why a group of engineers and scientists at the University of Texas at Austin have modified an enzyme, enabling it to gobble up all the PET plastic that pollutes our planet. PET makes up around 12% of all global waste and doesn't degrade quickly. But with this new discovery, it would be possible to recover and reuse plastics at the molecular level. They're calling it fast PETase, which stands for functional, active, stable, and tolerant. And it can break down plastics into smaller parts and spits out recycled new plastics ready to be reused. Our current recycling just doesn't work as well as it should, since less than 10% of all plastics are recycled. And up until this point, no one had been able to figure out a plastic-eating enzyme that would operate at low temperatures. The enzyme can complete a circular process of breaking down the plastic into smaller parts, depolymerization, and then chemically putting it back together, repolymerization. In some cases, these plastics can be fully broken down in as little as 24 hours. Way to go on creating an enzyme that eats PET, scientists. How about one that eats FAT? Can we get cracking on something to break this body fat down so I look like Chris Hemsworth even though I've been eating pizza all weekend? I know what you're gonna say, that I can get healthy and strong and hard work, a good diet and fitness, but to that I'll say, come on, science. Let's do this.
You're right. Why should we work at it? Why should we work at it? This is something that I think a lot of people would agree with. I think we can start a foundation for this.
Absolutely.
Is to not work for fitness.
Yes.
Just give me the fit pill.
Give me the fit pill. I'm ready for the fit pill because I have every intention. And sometimes I do work out. I do. I go for months and I get fit and I get in shape. And then immediately I have a real, delicious pizza. And my body shuts down and lays down and I don't move for about a day or two. And I go, I'm just going to stay right here. Yeah. I'm just going to stay in this state for the next 6 months.
Do you know that the FDA exists because somebody created a drug or found a drug that actually caused people to lose weight?
Really?
And they were so abusive of it, people overused it and were so crazy about it that it started causing death and cancer and all sorts of problems because it was just some person had figured out, here's this thing. At least this is the story I read. We can fact check me, but this is my understanding is that the FDA exists because this drug, which was everyone said was a miracle drug, turned out to be horrible for you.
Wow.
It absolutely destroyed your body. And so they were like, we need some way to tell people whether or not a drug is okay before we just start letting people have it and losing weight.
I did not know that. So jokes aside, of course I'm kidding. It's important to be healthy. It's good to take care of yourself. And when I refer to scientists inventing something that'll help me shed pounds and look like Chris Hemsworth, I'm kidding, of course, but that's wild. I did not know that somebody along the way was like, we figured it out. Yeah. You can pop this pill.
We got it.
And weight's off immediately, and then there were a lot
and everyone's like, yes! And they just started eating the heck out of it and just using it all the time, and then people started dying.
And it started doing terrible things.
It was turned out to be a disaster.
Was this in the 80s? Or
No, like 40s.
40s?
Like a long time ago.
Oh, no. Okay, well, never mind. I'm kidding. I'll work hard to look like Chris Hemsworth someday. Yeah. Maybe
the 30s.
Maybe
it was a long time
It was
ago.
a while ago.
Yeah.
It's okay. It's okay. I don't need to be Thor. I'm happy with my dad bod self.
You look like Thor to me. Come on. You're basically the same.
You're basically
Jacob, Chris Hemsworth, same.
Yeah.
Same. I can hardly see the difference. Very cool, though.
Very cool. Very cool enzyme. Cool. It is a cool story, and it's exciting to see anything that is a process to get rid of the current waste and issues that we have today, right? Yeah. That's what makes me excited about this. Is it's we have this massive plastic problem, and could this biological method, could this really get rid of or reuse all of that trash?
See, you hear me complain all the time. I was just complaining in yesterday's segment about how technology is it's making it so we can maybe feel okay about we can keep having bad water habits and so on. Well, in this case, I actually think this is a great technology. It's a great idea. Something like this is necessary because the fact of the matter is we have been doing this for almost a century of making plastics. Mm-hmm. And so finding ways to reuse or to make them biodegrade faster or to get them into into a situation where they're tenable is, to me, a good idea. It's the same as like figuring out more carbon capture technologies.
Yeah.
Like, yeah, I mean, it doesn't need, okay, we shouldn't say, okay, we can capture carbon, that means we should continue to just burn it into the air.
Right,
Just
exactly.
like, because we can find a way to dissolve and remove plastic doesn't mean we should continue to be irresponsible with plastic. I'm just saying that we have been doing it for so long that it's going to require technology to get us out of the problem.
Yeah, that makes sense.
And so it's a really good. I think it's a really good idea. This one's really promising. So I'm excited to learn about this one.
Yes, and I do have some talking points here. Before we end the segment, it says fast PETase, which I know
fast PETase.
PETase. I know it's almost laughable, but it's fast. That's the acronym, and then PET, the plastic, and then they end it with lowercase ASE, and that's how. So it's probably just fast PETase. Can perform.
You know what? Let's put it. It's right here.
Okay.
If you're wondering,
there it is.
That's how it looks.
That's how it looks.
Right there.
Can perform.
We just gave Veronica a job to do.
More to do.
Yeah.
It can perform at less than 122 degrees Fahrenheit, which is the ambient temperature needed for it to be effective in natural environments. This was a big part of it because people had discovered enzymes that could do this, but it needed to operate at like really, really high temperatures in order to get going. But 122 is very, very accessible in landfills and in these spaces where the heat can really rise quickly. And so that means that this thing could do it in an environment naturally.
That's great.
And that's really, really cool.
Yeah.
This discovery also came from several different scientific disciplines collaborating with artificial intelligence, machine learning, and generating novel mutations to create the enzyme. So like 3 different fields of study all came together to make this happen, and that's exciting to see. It was like they were like, if we work together, we could figure out how to make this enzyme. So it's very exciting.
That's frightening, isn't it?
Yeah, right.
Science is like we're changing enzymes.
Changing enzymes.
Next, we'll change your molecules so that you absorb plastic.
That's right. Yeah. That's right. Yeah. It is a science fiction film in the making.
That's where we are, folks. This is what's happening.
Yeah. Well, that's the story from me, and we'll have more for you soon.